So if you look at the title of this graph here, the claim is made that gravity of 10 meters per second was used. How could we verify that claim from using the data that we see here? Well, there's two ways that one might proceed. The first might be to take the kinematic equation without time. Vy squared is equal to Vy naught squared plus 2ay delta y, and solve it for a sub y. And if you do that, you get a sub y equals Vy squared minus Vy naught squared over 2 times delta y. And now if we go to the apex, at the apex, V sub y is 0 meters per second squared minus the initial y velocity. We calculated that in the previous lecture, and that is 19.3 meters per second squared. And the height reached is about 18.6 meters. You can read that off of here. And so if you do the numbers here, you will get something very close to 10 meters per second per second. That's one way to do it. A second way to do it would be to look at the flight time to the apex. We know what the flight time to the apex is because to get to the apex we have 1, 2, 3, 4, 5, 6 delta t intervals, each one of which is 0.322. So 6 times 0.322 seconds will be the time to the apex. Then we can use the kinematic equation that relates velocity, acceleration, and time in the vertical direction, which is this equation right here. And if I solve this equation for a sub y is equal to Vy minus Vy naught over t, which is equal to 0 meters per second. That's the velocity at the apex minus the initial velocity, 19.3 meters per second, in the y direction, divided by the time to the apex, which is 6 times 0.322 seconds. And again, if you do the numbers here, you will get something very close to 10 meters per second squared.